a balanced three-phase system with purely resistive loads, the neutral current is zero. However, unbalanced loads, such as single-phase loads or nonlinear loads, can cause a neutral current. Nonlinear loads, like elevators, draw harmonic currents that can distort the voltage waveform and increase neutral current. The National Electrical Code, or NEC, allows for a reduction in the neutral conductor size in certain situations. However, this reduction is dependent on the ampacity of the phase conductors and the load characteristics. For a 600 amp three-phase service, the NEC allows a reduction of the neutral conductor to 50% of the phase conductor ampacity, that is 200 amps, if the following conditions are met. Firstly, the nonlinear loads are limited to 20% of the total load, and secondly, the load is balanced. Elevators are nonlinear loads and can draw significant neutral current. The amount of neutral current depends on the size and type of elevator. It is generally recommended to use a full-size neutral, such as 250 kcmil aluminum, for a 600 amp three-phase service with a 20 horsepower elevator. This will ensure adequate capacity and minimize neutral current issues. If there are concerns about the specific load characteristics, it is recommended to perform a load analysis to determine the actual neutral current. This will help determine the appropriate neutral conductor size. Always follow the applicable codes and standards when determining the size of the neutral conductor. It is crucial to carefully consider the load characteristics and potential neutral current issues. Here's a deeper dive into neutral conductors in three-phase systems. Let's start with the basics. In a perfectly balanced three-phase system, where each phase carries an equal amount of current and the loads are purely resistive, the neutral conductor theoretically carries no current. This is because the currents in each phase are 120 degrees apart, and their instantaneous sum at any given time is zero. However, real-world electrical systems are rarely perfectly balanced. Unbalanced loads occur when different phases supply different amounts of power. This can happen due to various factors, such as uneven distribution of single-phase loads across the phases. When a load is unbalanced, the neutral conductor provides a return path for the difference in current between the phases, preventing voltage imbalances and ensuring proper operation of the equipment. Nonlinear loads are another significant source of neutral current. These loads, which include devices like variable frequency drives, electronic ballasts, and some types of elevators, draw current in a non-sinusoidal manner. This creates harmonic currents, which are multiples of the fundamental frequency. These harmonic currents do not cancel out in the neutral conductor like the fundamental frequency currents do, leading to a significant increase in neutral current. The third harmonic is particularly problematic, as it adds up arithmetically in the neutral conductor, potentially overloading it. The National Electrical Code, or NEC, provides guidelines for sizing neutral conductors in three-phase systems. The NEC recognizes that in many situations, the neutral conductor does not need to be the same size as the phase conductors. This is because the neutral current is often less than the phase current, especially in systems with primarily linear loads. The NEC permits a reduction in the neutral conductor size under specific conditions. Firstly, if the load consists primarily of nonlinear loads, the neutral conductor must be sized to carry the maximum possible unbalanced load current. This typically means sizing the neutral conductor the same as the phase conductors. Secondly, if the load is primarily linear and the neutral is not used for more than a small amount of nonlinear load, the NEC allows the neutral conductor to be sized smaller than the phase conductors. The specific reduction allowed depends on the ampacity of the phase conductors and the type of load. For example, for 600 amp three-phase service, the NEC may allow a reduction of the neutral conductor to 50% of the phase conductor ampacity, that is 200 amps, under certain conditions. These conditions typically include limiting nonlinear loads to a certain percentage of the total load and ensuring the load is relatively balanced. However, it is crucial to carefully consider the potential impact of nonlinear loads such as elevators on the neutral current. Elevators are often a significant source of harmonic currents due to the presence of variable frequency drives or other power electronic components. The amount of neutral current generated by an elevator depends on several factors, including the size and type of motor, the type of drive system, and the operating cycle of the elevator. In situations where elevators or other significant nonlinear loads are present, it is generally recommended to use a full-size neutral conductor, that is, a neutral conductor with the same ampacity as the phase conductors. This will ensure adequate capacity to handle the harmonic currents and prevent overheating or other problems. Before making any decisions about neutral conductor sizing, it is essential to perform a load analysis to determine the actual neutral current. This analysis should take into account all of the connected loads, including both linear and nonlinear loads, as well as any potential future loads. The load analysis can be performed using various methods, such as using load monitoring equipment to measure the actual current flow in the neutral conductor, or by calculating the expected neutral current based on the known characteristics of the connected loads. In addition to following the NEC guidelines, it is also important to consider any local codes or regulations that may apply. Some jurisdictions may have stricter requirements for neutral conductor sizing than the NEC. Always consult with a qualified electrical engineer or inspector to ensure compliance with all applicable codes and regulations. Using a reduced neutral conductor can save on material costs, but it's important to weigh the potential cost savings against the risk of overloading the neutral conductor. An overloaded neutral conductor can overheat, leading to insulation damage, equipment malfunction, and even fire. It's also important to consider the potential impact of harmonic currents on other equipment connected to the electrical system. Harmonic currents can cause voltage distortion, which can lead to problems with sensitive electronic equipment. Using a full-size neutral conductor can help to mitigate these problems. In summary, sizing neutral conductors in three-phase systems requires careful consideration of the load characteristics, applicable codes and standards, and potential risks. While the NEC allows for a reduction in the neutral conductor size under certain conditions, it is important to ensure that the neutral conductor has adequate capacity to handle the expected neutral current. Performing a load analysis and consulting with a qualified electrical professional can help to ensure that the neutral conductor is properly sized for the application. Now, let's look closer at the specific situation of a 600 amp three-phase service with a 20 horsepower elevator. Given the presence of the elevator, which is a nonlinear load, it's generally prudent to err on the side of caution and use a full-size neutral conductor. This means using a neutral conductor with the same ampacity as the 600 amp phase conductors. Using a full-size neutral will provide ample capacity to handle any harmonic currents generated by the elevator and other nonlinear loads, ensuring reliable and safe operation of the electrical system. While a load analysis can provide more specific information about the actual neutral current, in the absence of such an analysis, using a full-size neutral is a conservative approach that minimizes the risk of overloading the neutral conductor. If a reduced neutral is being considered to save on costs, a detailed load analysis is crucial. This analysis should determine the expected neutral current under various operating conditions, taking into account the harmonic content of the elevator load and any other nonlinear loads. The analysis should also consider any potential future loads that may be added to the system. If the load analysis shows that the neutral current will consistently be below the ampacity of the reduced neutral conductor, then a reduced neutral may be acceptable. However, it's important to have a safety margin to account for any unexpected increases in neutral current. It's also important to ensure that the reduced neutral conductor meets all applicable code requirements. The NEC specifies the conditions under which a reduced neutral is permitted, and it's crucial to comply with these requirements. The NEC also provides tables for determining the ampacity of conductors, and these tables should be used to select the appropriate size of the neutral conductor. Remember, electrical codes are in place to protect life and property, so it's essential to follow them carefully. In addition to the NEC, local codes and regulations may also apply. These codes may have more stringent requirements for neutral conductor sizing. Always check with the local electrical inspector to ensure compliance with all applicable codes and regulations. Finally, remember that electrical work can be dangerous. Always use caution when working with electricity, and follow all safety procedures. If you are not comfortable working with electricity, hire a qualified electrician to do the work. Electrical safety is paramount. In summary, for a 600 amp 3-phase service with a 20 horsepower elevator, it's generally recommended to use a full-size neutral conductor. This will provide ample capacity to handle any harmonic currents and ensure safe and reliable operation of the electrical system. If a reduced neutral is being considered, a detailed load analysis is crucial, and all applicable codes and regulations must be followed. Always prioritize safety and consult with a qualified electrical professional if you have any questions or concerns.